Unit 1 is on modeling with statistics. This first video will deal with a review of some basic statistical terms and formulas that you will need for the first lesson. Alright, let's begin with a review of the measures of central tendency. These should be very familiar to you. The measures of central tendency are the mean, median, and mode. The measure of central tendency is a number used to represent the center or middle of a set of data values. So we're going to use this example of a set of data values to find the mean, median, and mode. First of all, the mean, if you remember, is the average of the numbers. And you all know that when you find the average, you just add up the data values. And the sum of these data values is 72. And then you divide that sum by how many numbers you have, or how many values you have, which we have 9. So we're going to divide by 9, and that is going to give us 8. So our mean of our set of data values is 8. And if you remember, the median is the middle number. Now remember, to find the middle number, you always have to have your values in order from least to greatest or greatest to least. And we have it in order already. And so since we have 9 data values, we know the fifth number will be our middle number. So 9 is our median. Now remember, if we have an even set of data values, that you have to take the average of the two middle numbers to find the median. The mode, remember, is the number or numbers with the greatest frequency, or the one that occurs the most often. So if we look at our set of data values, 9 occurs 3 times, so it is the mode. Now remember, we can have more than one mode. For example, if we had another 7 in this set, then 7 would occur the same amount of times as 9, so 7 and 9 would be the mode. Or you might have no mode because all the numbers might occur the same amount of time. I would now like to go over the measures of dispersion. So we just talked about the measures of central tendency. Now we're going to talk about the measures of dispersion. Now measures of dispersion are used to tell the spread of the results. Right, the first measure of dispersion I would like to discuss is the range, which you are very familiar with, and it is just the difference between the greatest and least value of your set of data points. So we're going to use this new example for our set of values, 2, 3, 4, 5, and 6. So our range for this set of data values would just be 4. 6 minus 2, largest minus the smallest. Now standard deviation is another measure of dispersion, and it's the most common one used when describing the spread of a set of results. And you might not be quite so familiar with this measure of dispersion, but it is the typical difference or deviation between a data value and the mean. So, once again, the standard deviation is the typical difference, or what we call the deviation, between a data value and the mean. So, of course, your first step to finding the standard deviation of a particular data set would be to find the mean of the data set. So, the data set that we are using for our example, remember, is 2, 3, 4, 5, and 6. So, to find the mean, remember, you just take the average, so you add them up, and you divide by how many you have. So when you add up 2, 3, 4, 5, and 6, you get 20. You divide that by the number of values that you have, which we have 5. So that means our mean for this particular data set is 4. Now your second step is to square the difference between each of these 5 values and its mean. Alright, so we have to find the difference between each value and its mean and then square it. So the first value is 2, so we're going to subtract 2 minus our mean and square it. So that would be negative 2 squared, which is 4. Then we take the next value, we subtract the mean, and we square it. So that would be negative 1 squared, which is 1. Take the next value, subtract the mean, and square it. So that's 0 squared, which is 0. Fourth value we take, which is 5. Subtract the mean, we square it, that's 1 squared, which is 1. And then our last value, we subtract the mean and square it, and that would be 2 squared, which is 4. Now we want to square the difference between each value and the mean. So that is what we just did in step 2. Alright, step 3. Total this sum of those differences you just found from step 2. So we are going to add 4 plus 1 plus 0 plus 1 plus 4. So that is going to give us 10. Alright, so we first found our mean. We took each data value, subtracted our mean, and squared it. And then in our third step, we added the differences squared, and we got 10. Divide the sum, fourth step, divide the sum of these differences from number 3, which was 10, by the number of values in the set. Alright, so the number of values in the set, which was 5, so we're going to take the sum that we found in 3, we're going to divide our number in our set, and we are going to get 2. Alright, number of values in, I kind of left that out, so I'm going to write that in the set. Alright, so we took the number that we found from number 3, which was the sum of the differences squared. We divided that by the number of terms we have in our set, and we get 2. Alright, then you take the square root of that number you got in 4, square root of 2, which remember is about 1.41. So that is our standard deviation. Our symbol for standard deviation is this little Greek symbol, and it is going to be square root of 2, which is about 1.41. Alright, so kind of go back through these steps. You first find the mean, which you know is the average, and we got that to be 4. Step 2, we subtracted each data set, well, the mean from each data set, and squared it. So we got 41014. Step 3, we totaled that sum that we got and got 10. Then we divided that by the number of values that we have in the set, which was 5, and got 2. And then we took the square root. These are the steps to find the standard deviation. So that means the typical difference between each value and its mean is about this 1.41, or square root of 2. Now I would like to show you the formula that illustrates these steps that we just did to find standard deviation. Alright, so remember, I already showed you that this symbol here, which is sigma, it is a Greek symbol that represents standard deviation. So that's why we have here sigma equals, or standard deviation equals. And then the x bar, that's how we say x bar, is the symbol for the sample mean. So for the mean of the sample of data. And x sub n stands for the nth value in the set, because n stands for the number of values in the set. So the nth value in the set, which in this case, you know, the last value, since n stands for the number of values in the set, x sub n represents the last value in the set. So remember, when we found standard deviation, the first thing we did was find the mean of the sample. So we found x bar, and then we subtracted that mean, or found the difference from that mean in each of the data values. So that's where this x1 minus x bar comes in the formula, x2, the second term, minus x bar, or the mean, all the way to the last term in the data set minus x bar. And then remember, we squared each of those differences, squared each of them, see, squared each of these, and then we added each of those, all right? And then we divided that by the number of points in the data set. And then the last step, we took the square root, and that gave us the standard deviation. Now, a shorter version of this formula is to use the symbol, which looks like this, and it stands for the summation. Summation, that is an A right there. Alright, so we could take this formula and make it a little bit smaller, which makes it a little bit easier. We use the little summation symbol to say that we are adding, and we take each of the data points and we subtract the mean of the sample, we square it, and we divide that by n. And that is a little shorter version of the formula. The last term that I would like to review is outliers. Outliers are values that are much greater or much less than the other data in the set. So they are way off from the other numbers. And they skew the mean and standard deviation, of course, and so we typically remove them when we calculate any statistics for the set. Now remember, you must complete your WSQ, which is to watch the video and take notes, summarize what you learned, and make sure you have a minimum of 3 sentences, questions that you may have about the video, or make one up if you do not have any questions, such as a higher order thinking question that we may answer tomorrow.